All right, this is section 2.1 from Algebra 2, which is talking about representing relations and functions. First thing we need to do is we need to talk about a couple vocabulary words. I'm going to go over these quick. They're right in the book if you guys want to write down the definitions yourself. But a relation is mapping or pairing of input values with output values. What the domain is, that's the set of input values. So the domain is all the input values that you can have. And what the range is, that's all the output values you can have from the function. And when we're talking about relation, we're talking about mapping, here are the different kinds of representations that we have. There's a table, ordered pairs, a graph, and mapping. Again, I'll go over examples of these in a little bit so you guys don't patiently, you can wait. We'll get to that, I promise. First thing, let's talk about what is the domain and what is the range. Generally, when we're talking about this, we're using functions for it, so your x's and your y's. So y equals 2x plus 3. The domain is the numbers I can put into it, so like x values, 2, 3, 4, etc., etc. And the range is what comes out of that function. So let's do some examples here quickly so you guys can see. So using mapping, here's two examples of mapping. The one on the left is generally our input, and the one on the right is generally our output. And what you have to look at is, so basically our inputs, this is going to go and it's going to come out, we'll put it in as a -3 and it'll come out as a +9. We'll put it in as a +7 and it'll come out as a +9. Nothing will actually come to be the output of any of our inputs of 1, but we just put that one in there. Again, over on the right one, we have our input and we have our output. That means that when we put a 4 into our function, we will get out a -1. If we put a 4, we'll also get out a 2. If we put out a 5, we'll get a 2, and if we put out a 6, we'll get a 3. Those are our input to our outputs relationship. Now we need to go look at graphing. So what a graphing relationship will look like is something like this. There's a parabola. If you guys don't know what that is called, it's a parabola. That's your x's to your y's, graphing it. Another example would be the circle. Another example would be the straight line. That's the negative straight line. And then the last example I have for you guys is one that looks a little bit strange to you guys right there. Now all of those are examples of mapping. Now before we go on, I want to talk about what makes it a function versus not a function. Really, to be a function, what you have to have is you have to have one output for each input. What that means is that I can't put in the same number into my function and have a different number come out. So for instance, in the first example of mapping here, I have -3. It only can come out as 9. So that's okay, that works. And 7 can only come out as 9. So from left to right, it works perfectly. So our first one is indeed a function because it only has one output for each input. Our second function that we did, if you look, right here is where we have an issue. Our 4, which is an input, it can come out to be either a -1 or a 2. Because it can come out to be two different numbers, that 4, this is not a function. So if you guys look, it might get a little confusing. Over on the first one, we have the same output with multiple inputs. That's okay. You can still have a function with the same output with different inputs, but you can't have it the opposite way. You can't have one input with two outputs. Again, what we want to do is we want to look down on the mapping. The graphing. These ones are going to be a little bit easier to tell. Basically, what we do is what's called the vertical line test. So I'm going to make a vertical line here so you guys can see straight up and down. And then what you do is you take that vertical line and you move it from left to right. Some people like to just use their finger. But if you bring it from left to right, notice that it never hits more than once on that graph. Because it doesn't hit more than once on that graph, this is a function. Now that might be a little confusing for you, but wait until I get to this next one on the right. Notice the circle on the graph. When I pull this over and I go from right there, notice it's hitting on 2 points on the graph. It's hitting on that vertical line. It's hitting here and it's hitting here. Because it's hitting multiple places, that's telling you there's multiple outputs for that one input. So that means this is not a function. It is not a function by the vertical line test. Now let's go down to these other two. Again, I'm going to take my vertical line. I'm just going to move it from left to right, going over. Notice it doesn't ever hit more than once on that line or on that graph. So because it doesn't hit more than once, this is a function. Let's go over to the last graph, and you can look right when we start, it's hitting twice again. It's hitting here, and it's hitting here. And you guys can see it's hitting multiple places in there as well. This is not a function. Not a function. All right. All right, now we're going to talk about evaluating expressions and equations. So evaluate, what that means really to solve, to plug it in and figure it out. So if we look at this problem, we need to evaluate. Now this is function notation. What it's saying is that f of x equals x squared plus 2x minus 3. Now when it has f of 3, what that is saying, for every time you see the x in the original function, you're going to plug in a 3. So for instance, for this one, f of 3 is going to be 3 squared plus 2 times 3 minus 7. Notice that every time I had an x in my first problem, or my original equation, I replaced it with a 3. Now we just solve from there. So we're going to get 9 plus 6 minus 7. 9 plus 6 is 15 minus 7 is going to equal 8. So let's try it again with negative 2 instead. So it's going to be negative 2 squared plus 2 times negative 2 minus 7, which is going to get us 4 minus 7. 4 minus 4 is 0, minus 7 is negative 7. That's how you evaluate. Now let's try a trick question here where we have g of x equals 7. Well, if you look on that, we don't have any x's. So really, where are we going to put the x? Well, there is no x, so g of any number we put in is going to automatically equal 7. No matter what happens, it's always going to equal 7. For instance, if I have $5 and you work 20 hours, how much will I have in my pocket? I will still have $5. It doesn't matter how much you work. I'm not going to get paid more money, right? All right. So on your own, I want you guys to evaluate this expression, or this equation, sorry, and I'll put up the answer here in a second. See how you did. All right, here's what I got. Go ahead and pause and check your answer. All right, now we're going to talk about graphing. I think you guys should be able to graph on your own. I won't make a table or whatnot to graph for you, but if you do need to graph using a table, make a table and graph the points. Remember that you could also use the slope and the y-intercept in order to graph. We'll talk more about graphing in the next couple of sections. But the best thing right now would be to make a table and use the same points all the time. What I would do is I would take the table, x's and y's, and I'd always use negative 2, negative 1, 0, 1, and 2. Then you plug those points into your equation in the input, so your x value, to come out with your output, your y. I already have the graphs made for these so we can tell if they're linear or not. So what a linear function is, well, we'll talk about that in 1 second. But first, here is a linear graph. That graph right there is definitely linear. The next graph up here, negative 3/4 x minus 2, if you look at that, that is also linear. If you notice those two lines, what makes them linear? Well, they're straight lines. They're straight connected lines that go infinitely long either way. If I look at this next problem here, it's a quadratic problem. That is not a linear graph. The reason it's not a straight line. If you look at that, that's curved. That's not straight. Another thing that makes it so that it is a linear function is that for every input there is only one output, and vice versa. There'll only be one output for every input, and every output will only have one input as well. So the square root of x, that's going to look something like this. It takes the parabola, puts it on its side, and cuts it in half. That is also not a linear function. So when we're talking about linear functions, we need to think about, well, what makes them not linear? The first thing is, well, it's not a straight line, right? That gets rid of anything that makes it curved. If you see a curved graph, you know that's not linear. If it's broken, what I mean by that, not connected. If it's not connected and going on infinitely long, it is not a straight, or is not a linear line. Another thing you could look up here on is to notice, look at the x values compared to the other ones. The x value is not raised to a power, or it's not, doesn't have a radical around it. So it just has a regular x in the function. Another thing you could think about is that for every input, there is only one output, and vice versa. Hope I spelled that right, I might not have, but vice versa. So what that means is that for every input there is only one output, and for every output there is only one input. Sure, there are a lot of other things that make linear lines linear, but those are really the ones to make sure you focus on there. If it's anything raised x to any other power but 1, it's not going to be linear. If it's not a straight line, it's not linear. If it's not connected, it's not linear. So what I mean by not connected, I'll draw you guys a graph real quick on top of my first one here. So if I have a graph, I don't know, that goes like that, and then it stops there, and then over here kind of breaks down and goes over to the right like that. That is not connected. Notice that those 2 points are not connected on them. That makes that not linear. All right, that's all I have today on section 2.1. So please feel free to let me know if you have any questions, rewatch the video, whatever you need to do.